Nature still has many surprises hidden in materials we can hold in our hands. Even after centuries of physics, there are entire regimes of behavior that we are only now beginning to explore, because we are still learning how to ask the right questions. My research asks a simple but very deep question. What new forms of matter emerge when quantum effects become collective, macroscopic, and strongly intertwined? In many materials we use every day, electrons behave more or less independently. But in quantum materials, electrons interact so strongly that they stop acting like individuals and start behaving as a coordinated system.
Quantum matters are referring to materials where the quantum mechanics plays an essential role to explain the behavior.
These are states where the material organizes itself in a qualitatively new way.
His area of research in quantum materials is a priority, not only in the physics department, but in engineering and so on. He is leading the front in this.
The paper I'm being recognized for focuses on a class of materials called van der Waals multiferroics.
Van der Waals means that it's layered, and multiferroic means that the material couples the electric and magnetic degrees of freedom in a very strong way.
They're especially exciting because they combine strong quantum effects with extreme tunability. We discovered a phenomenon called giant chiral magnetoelectric oscillations. And in simple terms, magnetic motion in the material can drive electric polarization in a handed or chiral way. What surprised us was the scale and robustness of the effect.
The size of the coupling, the strength of the coupling was beyond any material that has been previously reported.
It was a strong, well-defined response that shows these couplings can be both powerful and controllable. That fundamentally changes how we think about linking magnetism and electricity in quantum materials. The discovery provides a new physical mechanism for converting magnetic dynamics into electrical signals and vice versa in atomically thin systems. It also opens the door to controlling information at very high speeds.
This has direct applications for data storage and processing information, both classical and quantum. They could potentially form the next generation of transistors, next generation of maybe superconductors.
I see him just continue his exponential trajectory, making discoveries that blows our minds.
Science is not all the time successful, and we take big risks. But when a discovery happens in the lab and we find new quantum states that we never thought about, that's just exciting.